profiler. This system, soon on power off, the system boots up into Windows 3.11 operating system, and this screen shows up. And once you click on the profiler, the actual application will start, and it starts with the system initialization. And first the tower goes up, it raises up to the 0 level, that is all the way to the top, and the stage also initializes. And before power up, it is always safe to remove any samples left on the machine. So also this once the unit is initialized, this screen pops up, and here there are various icons to start operating the system. There are various menus in every icon. This is the configuration menu, where the system configuration and the substrate configuration can be changed. And also at any point of time, the system was designed in such a way that new options can be enabled on the system. Currently the system is already pre-configured, so no new changes are to be made, excepting teaching the lowest elevator position, which is how low the tower will go down to touch the sample surface and focus the image. And the lowest elevator position value will appear here in micrometers, and in the user's manual it is explained how to set the value here. After the touchdown, the number here should be corrected to add about 150 to 200 microns, so that no further down travel will be possible. This is only to enable the tower crashing onto the sample and causing various other problems. Also, the manual load position can be taught, and this system has no handler, but the handler load position also can be enabled if at any point of time it is retrofitted with a handler. And then soft home is where the Z level is to go whenever the soft home is enabled. It helps the tower not to go all the way top to the 0 level. So the elevator all the way up position is 0 microns, and it is about 62 millimeters of travel, and in microns it is 62,698 micrometers. And also there are leveling offset. The software leveling is possible, and here and also the theta can be changed if a specific orientation is required in degrees. And then the manual load position can be adjusted, and by going into teach manual position, these manual load position values will be changed. So anytime something is updated here, when we log out of the screen, it will prompt you to update the values and save them. Also, there is a calibration manual here. Various calibrations are possible or enabled. All these buttons, the first one is stylus force calibration, and during the maintenance routines the force calibration needs to be done. This system is already calibrated, force calibration is done, and the values are updated. And the video calibration is to enable the location of the videos This particular machine has two views of the stylus tip, one the top view, and then there's a front view which helps to view exactly where the stylus is touching on the sample. So I'm going to show how it works in a moment. And then there's also a scan position offset calibration provision provided, and linearity calibration to be done by factory certified technicians or engineers. And the step height calibrations time to time when the system is being constantly used. Known VLSI standards are to be used for step height calibration, just to make sure that the system is measuring right. And I have some standards here, but these standards will not be included with this machine. If sometimes they are available, we also list them on our website, or our sales assistant will be able to help you with that. And radius of curvature calibration, it requires a special tool to do that. And the video lamp balance is the system is the lamp illuminations for the video camera is automatically adjustable, and depending on the surface quality of the sample, the lamp balance is to be adjusted. And this drop timer also is a provision at the time of hardware maintenance. So we have database file managers. So this system is with Windows 3.11 operating system, and the hard drive used is a flash memory module with about 2 gigs of memory in it. So in case the system operating system or the files are backed up, only the provision exists in the floppy disk, or the flash memory can be connected to a external drive and copied, and we do keep a backup copy available with us. Now there is a CD-ROM drive on this machine, but because of the operating system currently it is not powered up and enabled, so just ignore the CD-ROM drive on this machine. So in the database file manager, we can do various transfers. We can export and import the files to and from the floppy disk drive, and the provision exists to connect an additional hard drive inside the system. There is a port available, and any hard drive less than 2 to 4 GB can be connected and used as a backup drive for this system. So the data it provides additional memory space. Now by clicking on export, we can choose a drive, and the user manuals it is explained how to select these options. The machine will be included with a operation manual and a reference manual, either a hard copy or on a DVD. On this system, the stress option is not enabled. Also, the GEM semiconductor equipment communication system is not enabled, and diagnostic tools are enabled, and it exists, but only trained personnel should access this menu. And there are various features available on this machine other than these screens here. So I'm going to also show one more thing. In order to log out of the screen, press the shift button and then use the mouse. It is a a 9-pin serial port mouse and click on log off, and that will exit this screen. So in order to log in back again, so I'm going to completely log out of the Windows session. So the system has a DOS 6.22 operating system on it, and once it is out of Windows, we have to go back to the Windows screen by typing in Win, and then click on Profiler, and I'm going to, this will show how the initialization of Profiler system startup happens. So the tower is going up. So in case of a 6-inch or 8-inch wafer is to be loaded, there's a stage vacuum provision exists. Right now I'm not using a wafer, so I have disabled it. I'm going to demonstrate. So there's it's a manual vacuum operation on this machine. So this toggle switch here is a pneumatic switch. So you load the wafer and then you enable this vacuum switch so that the wafer is held on the chart. So that is a quick initialization of the stage. Now we are going to scan. That is the main operation screen here, and once every time you get into scan, it will be showing you the last recipe that was used, and then you double click on it if you want to. So there are various this is the list of recipes available, and then also there is a button here for scan data. Whatever data after scan you have saved, they will be listed here. And then I'm going to show how a scan recipe looks like, and here it is a 2D scan only. This system is not for 3D measurements, it's only a 2D linear surface profiling system. So here there are various parameters. The scan length can be adjusted or taught, and then scan time, and depending on the length, the time is displayed here, and then scan speed also is a factor that determines the scan time. And then there are various options are available for sampling rate. The data can be sampled at a high rate as high as 1000 hertz or as low as 50 hertz. And then and we can also run multiple scans and average. So on the same zone, it will scan multiple number of times, and the average of those will be displayed. And the scan direction is possible to change it. Two directions are possible. We can always during the scan, only the stage is moving along y-axis, so that has to be noted. And there are for the x and y-axis, there are dual speeds, x fast and slow speed sections. And then the stylus force can be changed, and the contact speed is at what speed the stylus tip touches the surface of the sample. And the vertical ranging on this microhead 2 sensor, there are 3 ranges available: 131 micrometers and 26 micrometers and 6.5 micrometers. So this is the basic scan parameter definitions. And now there are feature detection provision available, and then various filters can be selected, and the general parameters, what you want to measure, such as step height or average height, and various other things, total area, slope, radius. All these details are described in the user's manual. And then you have other parameters. These are the general parameters, and then the roughness and waviness. So these, when the surface quality to be analyzed, and these parameters can be enabled, and we can have these parameters measured, and the system will display them after every scan. And these are the bearing ratios. If in case these details are to be enabled, please refer the manual. And then these are other parameters depending on the usage of the machine can be enabled. The high spot count or peak count, where a scan is done over a number of peaks and valleys, and these we can measure the height. Also the mean spacing can be measured, and the peaks can be counted. So all these parameters are possible to enable in this unit in turn, and all the measurements are done in angstroms here. So, and this there are other buttons here. So this is the data view, or we can go back to XY or theta view. This one displays the actual operation screen and the sample surface. The video signal is overlaid on the graphics of the system, and the video board used is Creative Technology CT6042. So once the screen appears, at this moment we know the tower is all the way up. So I have already placed a sample, and I'm going to focus the sample here. So we can see the stylus tip from the front view mirror assembly, and this one represents the wafer, and it's currently going to the X0 and Y0 coordinates, and you can see the Z-axis values changing, and it is. So this screen, on this screen we also have a zoom in and zoom out provision. We can zoom in onto it when the features are very fine, and for very narrow features we can use zoom in and magnify the video image of the screen. And there are 3 speeds of X and Y axis motions available here: slow, medium, and fast. And these up and down arrows represent movement along y-axis, and so these left and right represent the movement. So I'm going to use the medium speed and move it. So if you select slow speed, then you can click on the left button on the mouse, and you can see the stage moving at a very slow speed. At the end of releasing the button, the stage seems to be settling down and is normal. And also there is a theta, which is you can rotate this sample along a vertical axis. And this is elevator up. You just click of a button, it moves up, and the focus is we can see this is the front view of the stylus tip, and this is the top view of the image. And I'm going to zoom in and show how it zooms in onto a feature. Yes, and this is zoom out. So I have selected a location on a sample which is about 9,000 angstroms, and this blue line indicates the scan zone and location. So if I click on start here, this scan will begin. So right now the stylus moved up, and then it will go down at the selected speed, and this is touchdown, and it is going to scan. During the scan, a trace will be visible when it starts counting, and right now I have selected the lowest step height measurement level, so you can see it has detected a step. So that's the low range scan, and at any point of time the scan can be stopped. So that's the first measurement here. So in this screen, this is the analysis screen here. We have various buttons available. This is the measurement scale, and right now the measurement cursors are allowed to move because measurement button is enabled. And this is a normal scan. We can have a wavy scan or a roughness scan, wave scan and roughness scan display. And usually I use normal scan because we are doing those measurements. And then so it indicates once you select the cursors, one at the lowest before the step, and one is at the step, two cursors with some predefined cursor width, which is selected in the recipe. Right now the step height measured is 9,459 angstroms, which is pretty close to the standard we have, which is about 9,400 angstroms VLSI standard. Now, sometimes if the profile is not leveled because of the sample variations or the slight tilt in the stage, so you click on the level. Now, if you click the level, when you select the level cursors can be moved. So you have to move the level cursors to the same level zone, and then you click the level again. So that stage, the profile will be leveled with respect to the leveling cursors. So I'm going to show what happens if the leveling is not proper. See, right now I selected the wrong zone. I have selected the level cursor to be on the step here, so it resulted in a tilted scan. So if a scan appears like that, then you have to enable the level and move the cursors on either side of the step and press the level button, and it will be leveled again. So there are various other statistic parameters. I have selected all these surface parameters to be measured and displayed. So these are displayed here, and this system gives a provision to save this data on the hard drive or on the floppy disk, and also they can be printed provided a proper printer is connected to this system and the drivers are loaded using the line printer, the 25-pin line printer port. And so once these are done, we go back to the main screen again, and so we can edit a recipe at any point of time in this screen as well, and then we can display the surface summary, and then we have so these are various operation options also listed here. So at any point of time, this system software should not be upgraded unless the manufacturer is helping to do so, because changing the software or any hardware on the computer will cause various interface problems. So the system has a interface board in the computer here, and this machine is fully powered from the computer itself. So there is no separate power to the profiler, and this is the computer here, and there's a dongle here with a semiconductor chip on it on the printer port. Without this dongle, the system won't operate. And there's a video graphics VGA board and the CT6042, the Video Blaster SC100 is over here, and this loop back cable has to be connected as shown here, and I will be marking them when I am packing the machine. And these two connectors, the scanner power and the scanner data cables, are to be properly connected on this end. And also there's a video zero signal which goes from the camera to the PC is through this BNC connector here, and these are the cables, the scanner power and data cables connected to the machine here. Now the monitor can be placed on top of the system if necessary, but this cooling fan in the PC could cause minute vibrations, so I have chosen to separate them. So the profiler is on one table and the PC is on the other table. But the cooling fans are not that rattling in this machine, so if the PC is kept on the same table, it might work, but it is recommended to keep it on a separate table or just to isolate the vibrations. So there's a built-in vibration isolation table on this system. It can take care of it also. This is the vacuum connection here. So if you turn on the vacuum, so the vacuum pump can be connected, and the system will be shipped with the shipping brackets on the tower, and I will explain to you how to access those shipping brackets. So you have to reach for two knobs like this on this left-hand side panel of this machine. And just I'm going to give a bird's-eye view of the system from on the left-hand side. So there are door interlocks here, and so this is the inside view of the tower. But when we ship it, the tower will be not that close to the table, and the proper brackets have to be removed. There will be a turnbuckle clamp here, and for the stylus there will be clamping mechanism to avoid any kind of vibrations during shipping. So if necessary, the top lid is to be open for any kind of assessment. There are screws here on both sides. First open the side covers and loosen these screws. This top lid comes off. So I'm going to scan a couple of more standards and demonstrate the system is working in all the various ranges. So let's go back. So this is a 9000 angstrom standard, and I'm going to scan it one more time. So slower the speed, the longer it takes to scan. And during the scan, please avoid touching the table or leaning on the table, because that could cause small vibrations and will definitely affect the results. So this is a 9500 angstrom standard, and it is showing 9457 angstroms. That is pretty good. And then I'm going to go to a standard which is 1.8 microns, and I raise the elevator slightly, and then I'm going to select the faster speed and move this sample so that I will be able to focus it on the next sample. So I'm going to focus it again so that I can view the patterns on the vapor sample correctly. So I'm going to run a scan here. So I want to change the recipe to a different whenever you're trying to close the analysis window, the data has to be saved. Do you want to save it? If you want to save it, then you can proceed with yes. Otherwise, you can choose not to save it. And I'm going to select the medium range scanning program I have here, and these are the parameters again. So the vertical ranging, I've selected 26 micrometers. The last scan was 6.5 micrometers. So once we selected the medium range, then we go to so I have a step here. I can scan and display, see the results. So care to be taken, the surface profilers are very sensitive to the ambient turbulent air currents, so always close this windshield screen, and also avoid any contaminated samples. So cleaner the sample, better the condition of the measurement. So this is a valley measurement. This is a sample with a step down valley. This sample is a standard, which is about 1.8 microns, and I see 18,269 angstroms, which is pretty accurate. Going to go to another sample here, which is a different range. So here is another sample. Now let's scan it here and see. So depending on the offset settings, the stage will move, but we can see where exactly it is running the scan. So this is I'm using a stylus force of 5 milligrams, and it is desired you can increase it or decrease it. So this standard is about half the 9,000 angstrom, which is 4,500 angstroms, and the talus, the step height measured is 4431 angstroms. These are used standards, and they have been used to only verify that the unit is functioning properly. So I have another standard which is lower than 1,000 angstroms, and you can verify that it is working. So this is a very small step height standard, and first I have to level the craft. So I'm going to level it on positioning the cursors on either side of the step height, and now I'm going to select the measurement cursors and position it in the step on one side. And so this is a 450 angstrom standard, and it is accurately measuring for step height is 445 angstroms. So when we have a cursor width selected in the recipe, it helps to, so the cursor widths are selected here in the cursor. So you have a left measurement cursor, x1, x2 is the beginning and end of the cursor position, and the right measurement cursor also you will have a left hand and right hand side position values. So in this one I have selected about 50 microns of width, and also the leveling cursor. So what it helps to average the readings instead of having a single position cursor or a single line cursor. So this is also there is an interesting feature on this, that is the system can detect a feature as an up edge or a down edge or a down base or up base, and this is an additional feature, and then when we select this, then we have to position the cursor relative to the up edge or down edge. So now I'm going to select a very high step standard, which is about 8 microns, and show this system is functional. So before I change the samples, I'm going to show how the stage works. I clicked on manual load, so I have the sample stage moving all the way out. Same time the tower is going to its home position as well. So these profilers are very delicate, so use always powder-free gloves, and always watch the tower position when you are switching from a thinner sample to a thicker sample, which is very important. So here it is a 7.8 micron sample here. So I'm going to position it in the center and click on the manual load, and then we change the sample, so we have to focus it again because the tower, during the manual load, always the tower goes to the zero location all the way to the top. So these brackets will be placed on the stage, and this foam leaves the sensor locked in its position. So before powering up the system, please remove these brackets and make sure you save them for any time to relocate the system again for future use. So now So the larger the step height, we have to always use a higher range option in the recipe, but this system, this particular scan works well even in the mid-range. So this is a etched out glass sample. As I mentioned, it is about 8 microns in step height, and you can see here the step height is 80,338 angstroms, and pretty close to what it is, 8 microns. So I'm going to switch to one very large sample I have here, which is 23 microns, and this is it. So I want to switch to a recipe which is high range recipe. Sometimes you can edit the same recipe, but I'll switch to a high range recipe, and I'm going to just quickly scan it. So the trace looks pretty level, so the measurement also tallies the numbers that we are looking for, which is 23.73 micrometers.